Welcome to Code Report. I'm your host, Connor Hoekstra. Last week we had 6 contests, starting off with the Topcoder SRM 735, and that doubled as round 2C for the TCO 18 tournament. We also had from Code Forces on Wednesday, Educational 46. We had from Code Chef on Saturday, the Lunchtime contest, as well as the weekly Leak Code Contest 91. And on Sunday, just this morning, we had from Code Forces round 493 and from Hacker Earth, the July Easy contest. Taking a look at the top 10 leaderboard on the left, the 2 top 10s are from the Hacker Rank Week of Code 38 and the Hacker Earth June circuits. These contests finished roughly 2 weeks ago, but it was just after I posted the Sunday video, which is why I'm showing them now. So TM William took the top spot in the Hacker Rank contest. We also have the Topcoder SRM 735 leaderboard, some big names on the Division 1 leaderboard: Tourist in first, Petra in second, Umnik in third, also Case on 48, and XUDYH in 9th, who was the TCO 17 winner. Taking a look at the next top 10 leaderboards, from Code Chef June lunchtime, we had Tourist or Gennady taking the top spot. We also had TM William, who won the Hacker Rank Week of Code 38 in 4th, and we had Yui scattered about on multiple leaderboards, so 6th in both the Code Chef lunchtime and the Leak Code contest, and 10th in the Code Forces round 493, and some other big names on the Code Forces Div 1 leaderboard as well: Case on 48, Fate Ice, Swistak, Umnik, and Petra. So taking a look at the overall updates to the top 10 Code Forces, overall we had some movements. So Tourist still in first, Fate Ice jumping 2 spots, no change for Umnik, 000 dropped down 2, Silo Viale, there was no change there, or for Petra. Swistak jumped up onto the top 10 leaderboard into 7th, MNBV Mar jumped up 1 spot, Raid Wooch dropped 2, and Dodoria dropped 2 as well. In today's video, we're going to be covering the solution to problem C from the Code Forces round 493 contest entitled Convert to Ones. The problem states you've got a string A1 to AN consisting of zeros and ones. Let's call a sequence of consecutive elements AI to AJ a substring of string A. You can apply the following operations any number of times. Choose some substring of A and reverse it, paying X coins for this operation, or you can choose some substring of A and replace each symbol to the opposite one and pay Y for this operation. So you're basically, for the second operation, inverting the elements. And you can apply these operations in any order, and you're allowed to apply the operations multiple times to the same substring. And the question asks, what is the minimum number of coins you need to spend to get a string consisting of only ones? And the constraints for this problem are going to be the length of our string A is going to be between 1 and 3 times 10 to the 5th. So that's pretty big. And then each of the coins that we need to pay for either of the operations are going to be between 0 and 10 to the 9th. So let's take a look at the examples that Code Forces provided us with. So here are the 3 examples. For our first one, we have a string length n of 5. Our string down here is below 0, 1, 0, 0, 0. And for the first operation, that's the reversing of a substring. It's going to cost 1 coin. And for the second operation, that's the inverting of the elements. That's going to cost 10 coins. So the optimal solution for this is going to be doing a reverse on the first 2 elements. So you're swapping the 0 and 1 so that you get 1, 0, 0, 0, 0, and then doing an invert on the last 4 elements, which will change these zeros to 1. So that's going to be 1 X operation, 1 Y operation, which is going to cost 1 plus 10 is going to be 11. And for the second example, it's the same string, same number of elements, obviously, but the costs of each operation are swapped. So now to do a reversal, it costs 10, and to do an inversion, it costs 1. And for this, the optimal solution is just going to be inverting each set of zeros. So we're going to invert. So the first one, we just take this set of zeros and invert it to a 1, and then we're going to take the last 3 and invert them to 1. So this is going going to be 2 y's, and they only cost 1 each, so this is going to be 2. And then the last example here is a trivial example. They're all 1s, so we don't need to perform any operations, so this is going to output 0. So that's some examples to see how the problem works. So let's try and read into what's happening in these two by looking at a little bit more complicated of an example to see what we need to do to solve this problem. So here is a little bit more complicated of a string. We've got some alternating 1s and 0s, and there's 10 elements in it. And basically there's going to be 2 different approaches. There's going to be one approach we want to take when it's cheaper to reverse substrings, and then there's one approach we're going to want to take when it's cheaper to invert substrings. So in terms of when it's cheaper to reverse, basically what we want to do is we want to find the rightmost 1s and then reverse so that we can collect all the 0s in the middle. So we don't need to worry about the rightmost one, but the second rightmost one will be this one. And so if we find these and then sort of get the substring that has a 0 and invert this, it's going to group this 0 with these 0s here. So if we do that, that's going to be one reversal. And then we find the next sort of set of 1s next to a 0, and that'll be these 4. And if we reverse that, now we have all our 0s together, and so we've minimized the number of inversions that we need to do in the case where it's cheaper to do reversals. So if it's more expensive to do inversions, we want to minimize that, and so we want to move around our 0s and 1s using reverses, and then just do one inversion on our 0s once they're grouped together, and then we have our set of 1s. So if you look at a couple different examples, what you'll notice is that the number of reversals that you need to do in order to get all your 0s together is going to be equal to 1 less than the number of groups of 0s that you have in your substring. And the reason for that is that, like I said before, you don't need to worry about the rightmost one, because it's basically you're creating like a sandwich with 1s on the left, 1s on the right, and 0s in the middle. So and each of the reversals that you need to do is going to be basically on a set of the 0s. So if we're ignoring one group of the 0s, then we need to do a reversal on every other sort of set of 0s with the 1s on the right of it. So that's going to end up being, if we count the number of groups that we have of 0s, if we call this C, we're going to end up doing C minus 1 reversals. And then at the end, we're just doing an inversion on all the grouped 0s. So if we're taking the approach where the reverses are cheaper, sort of the formula that we're going to use to calculate the cost is going to be C, which is equal to the number of groups of 0s minus 1 times the cost to reverse, which is X, plus the cost to invert, which is Y. So it's going to be C minus 1 times X plus Y, if we're taking this approach. The other approach is when inversions are cheaper. And if this is the case, all we really want to do is just find every single group of 0s and change those to 1s individually. And so that's just going to cost us C times the cost to invert, or C times Y. So once you've sort of worked out these two formulas by looking at some examples, that's basically how I just did it. I looked at the examples that were given and created a couple examples of my own, and then you can sort of figure out these formulas. Then you need to consider, well, in which cases do we want to take the reverse approach or the inversion approach? But the trick is that we don't actually need to figure this out. We can just take the minimum of the two. These are going to be constant time to calculate. It'll be linear time to get the C, but then each of these are going to be constant time, mathematics calculations. So we can just get our answer by taking the minimum of approach A and approach B. So the minimum of C minus 1 times X plus Y and C times Y. And note that there's a sort of, we're flooring it at 0, and we're just doing this in the case that we have all 1s. You're going to get potentially a negative number because our count C will be 0, so you'll end up with negative 1 times X plus Y. And so if X is greater than Y, you're going to end up with a negative number. And so you just want to make sure that you're flooring this result at 0. So basically, once you have this formula, all you need to do is count the groups of 0s and you're good to go. So in C++, this is actually really easy. There's a function, STL algorithm called unique. And what unique does is it removes all adjacent elements in a string or a vector or whatever container that you pass it. So given this string, if we call unique on it, it will basically return us 1010101. So it basically condenses our string to remove adjacent duplicates. Note we actually have to call this with erase in order to actually erase the end, but that's pretty simple. We don't have this in Java and Python, so we'll actually have to sort of calculate this value C manually. But yeah, that we're going to make use of sort of this formula plus unique in our C++ solution, and then in our Java and Pythons, we'll just sort of manually calculate this C and use the same formula. So let's take a look at our code. So here is our C++ solution. The first two lines here is just reading in our input. Note that due to the constraints of our problem, we need to make sure we're using a long for our values x and y. And then we're reading in our string. And so then on the third line, what we're doing is we're making our call to unique. So we're passing it in sort of the beginning and the end of our iterators to our string. And then this is going to return an iterator to the past the last element of our sort of condensed string. And so with that past the last element, we're going to use that to erase all the elements at that point and after. And that'll give us, this line will give us our condensed string. And so once we have that, all we need to do is call the count algorithm and count all the zeros that are in our string, and this will give us our value C. And so once we do that, we just plug in the formula that we calculated or came up with before, which is the max of 0, comma, the min of C minus 1 times x plus y, comma, C times y. And we just output this, and this will be a correct solution. So let's take a look at the Java solution. So as I mentioned, we don't have equivalent of the stood unique algorithm in Java, but we have this here to sort of replicate what we're doing there. So reading in our input here at the top, and we're initializing this Boolean on to be false. And basically what we're doing in here is we're using an enhanced for loop to loop through, and anytime we are moving from not being on a 0 to being on a 0. So when on is true, that means we're on a 0. If on is false, that means we're on a 1 or previously on a 1. And so whenever we hit the condition that our character is a 0 and we weren't, the previous character wasn't a 0, we want to turn on back on a true and do a pre-increment on RC. And then anytime we hit a 1, we want to turn on to false, because that means we're on 1s now. And so this will, in a few more lines, get us the value of C that we are looking for. And so once we have that, we just plug all our C, X, and Y into our formula once again, and this will get us the same result. And for our Python solution, a little bit more condensed, but similar to Java, we're reading in our input here, declaring our Boolean on to be false, and then we have the same for loop. So if our current character in our string is equal to 0 and we're not on, then we set it to true and do a plus equals 1 to RC. And then we just plug this into our same formula once again. So those are the three solutions in C++, Java, and Python, and they'll all get you a passing submission. And so the last thing to talk about is time complexity. So for this algorithm is going to be linear, because in the C++ solution, both unique and count are linear time algorithms, and for the Java and Python ones, the equivalent code is also linear time. Taking a look at the contests that are happening next week, tomorrow we have from HackerRank the 101 Hack 55 contest. On Tuesday we have from Codeforces round 494. On Friday we have the start of the Code Chef July Challenge, which is going to last just over a week. On Saturday we have from Top Coder round 3A of the TCO 18 tournament. And of course, finishing off the week, we have the weekly League Code Contest 92.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.